All right, so we're gonna look and see what pieces we remember from just before fall break, because both of these are from that week before we had that quiz. All of these things are gonna come back up again, so it's one of those things we can't just like forget it because we were on fall break. So on this first one, this was really how we kind of ended this, ended the review section. We started with our factoring stuff, where we have our, it's open, you're good. We had our ax squared plus bx plus c, and we're factoring that using our x in box. We have our a times c, the 1 that's in front of the x squared, and the number on the end. A times c, 1 times 6 is 6. B is the number in front of the x right here, so it's a 5. And we need a pair of numbers that multiplies to be 6 and adds to be 5. What pair of numbers multiplies to be 6 and adds to be 5? 3 and 2. So if we use the box to factor this, we take our x squared from our equation, our 1x squared. We have our 6 from our equation. And these two guys are how this guy uncombines its like terms. So we have 3x and 2x. So we're going to pull our factors in columns and rows. Shared between x squared and 2x is just an x. And shared between 3x and 6 is a 3. The common factor between x squared and 3x is just x. And the common factor between 2x and 6 is just 2. So it gives us our factored form of x plus 3 times x plus 2, and this all still equals 0. That was a whole lot of that I just threw at you at 7:20 in the morning on the first day back. It shouldn't be new. None of that part should be new. That's all stuff we did in Algebra 1. Bunch of times. Questions on that part? Okay, so the Algebra 2 part, how we get our solutions, that's when we take each of these guys and set them equal to 0. So we're going to have, oh, come on, x plus 3. I'm going to give myself some more space because I don't like this. There we go. We want to know, when does x plus 3 equal 0? And when we want to know, when does x plus 2 equal 0? Those are our two solutions. So on this one, to get x by itself, we subtract x from both sides. Or not x. We're going to subtract 3 from both sides to get x by itself. I want x by itself. So x equals -3. And then on the other one, we're going to subtract 2 from both sides. So we get x equals -2. And these are my two solutions. We have two solutions here. Whenever we have an x squared, we're going to have at most two solutions. And most frequently, we will have two solutions. Questions on those ones? Okay, because factoring is going to come back up today. Like, we are going to continue with the factoring stuff. Let's look over here at this one, our imaginary number stuff. When we have these negative square roots, this is when we're going to factor things out. I'm going to take this -25 and split it up to be -1 times 25. because I really don't like having a negative under my square root. I'm going to take the minus 81 and we're going to split it up. Minus 1 times 81. I'm going to leave them as 25 and 81 because those are both perfect square numbers. So when we break this down a little further and we get the square root of negative 1 times the square root of 25 times the square root of negative 1 times the square root of 81, I have things in here I can simplify. What is the square root of 25? 5. Do I put it inside a house? No. Once I've done the square root, the house goes away. I had a lot of people on the quiz square root 3 and 4 times because they just kept putting it in the house. So they just kept square rooting and kept square rooting and kept square rooting. Once we've done it, it goes away. Same thing with our 81. The square root of 81 is 9. Nobody left in the house, so the house is gone. The tricky bit here is the square root of negative 1 has a special name. That's the piece we call I. And I have another one of those over here. So I have I times 5 times I times 9, because these are all still multiplied against each other. I'm going to give us a little. So 5 times 9, that we can do. That's 45. I times I is I squared. I squared is all well and good, but we can simplify that a little farther. Because if we remember, I actually is the square root of negative 1. If we have the square root of negative 1 squared, what do we have left? Just negative 1. So this is 45 times negative 1, also known as negative 45. So our solution here is negative 45. Okay, questions on either of those two?
On future tests, do we have to show that?
No, if you can see where you're headed with it, the more steps you show, the more places it gives me options to find partial credit. But no, you do not have to write every single one of those steps. Give you something, don't just teleport to negative 45. But you don't have to write every single one. Okay. So, a little bit of real talk. For some of us, we need to have this conversation. I'm not saying this is for everybody, but for some of us. Does anybody actually want to take this class again? Want to take math in summer school? I'm going to go with no. Even I don't want to. You can. Nobody's grade is beyond fixing. Absolutely nobody's. But you gotta want it. Some of us need to want the change. I cannot want your grade to change more than you want to. Also, your grade's not locked in, so if you're happy with where your grade is, do not check out on me. You're halfway. Halfway through the semester, okay? I stay after on Mondays, and I am available 5th period on Wednesdays for like tutoring one-on-one time. There's also 21st Century Learning Center after school Monday through Thursday until 5. And they have tutors, and it's free. Okay, so you don't have to work with me. Some of us just need to lock it in. Unless you really want to take algebra again. Wait, I'll be here. I'm here. No judgment, but do you really wanna? Okay, moving on. We're gonna talk about factoring stuff some more. Yay! So notebooks out. We are going to be finishing up chapter, what are we in, 3 now? Yeah, chapter 3. This was one of those ones that got split across break, so we'll have another quiz in a couple more weeks. But we're going to go in with some factoring stuff, and some of them are a little bit special. We've got 2 special products here. On the left-hand side, it has it in its generic form, and in the right-hand side, it has it with numbers, so we can kind of see what's going on. Because you can absolutely still do these the exact way we just did, where we take our X and our box, and we go. On this one, what's that middle term? What is the B for our BX? What's this guy? On this one. 0. Okay, that would be the biggest mistake made on those. You can absolutely X and box it, 100% totally fine. This is a special pattern called a difference of squares. X squared is a perfect square, whatever the second piece is a perfect square. So 25. When we're doing that, there's a shortcut we can take that involves no X, no box, no nothing. I figure out what A is. So whatever my first term is, and I find out what my B is. And it's going to spit out a pattern for us. It's going to be my first term. Whatever the piece was that was squared. One has a plus, one has a minus. Which when we're only talking A's and B's, it looks super duper weird. Which is why I have the example on the right-hand side. Because on this guy, we have our square root of x squared is just an x. So both terms have an x in the front. We're going to look at 25. What is the number that was squared to make 25? 5. There's going to be a 5 in the back of each of these. One piece gets a plus, one piece gets a minus. Because this is a difference of squares. 100% still valid to X and box it. Yes, sir.
Are we going to do anything without perfect squares?
What do you mean?
So like, are we, instead of 25, would we do like 26 at even 25?
Oh, we shouldn't. Unless we're doing something with quadratic formula, because then it's just plug and chug. But so difference of squares only works when it's a perfect square. I'm never going to have you do difference of squares without a perfect square. You'll do that in pre-cal if you do that. You'll do that in pre-cal. Okay, so we have another special product down here. And again, I see a perfect square on the front and a perfect square on the end. But this time, it's not quite exactly the same. What this is going to give us is this is called a perfect square trinomial. This one is called a difference of squares. This is a perfect square. Because what this was is someone took term A and term B, used this operation, so this one's a plus, and squared it. This only works if the middle term is whatever this guy, square root of this guy, square root of that guy times 2. This is one of those ones that might just be easier to box it and notice what's happening. So I'm going to do the right-hand side one by boxing it. A times C, my 1 times my 16 gives me 16, and adds to be my B of 8. What's a pair of numbers that multiplies to make 16 and adds to make 8? 4 and 4. So when we put those in the box, and pull out our factors, what we're going to have is x plus 4 times x plus 4, also known as x plus 4 squared. I'm going to fix that x because that one looks real cray. So you can absolutely 100% still do these with the x in the box. Totally fine, 100% valid. There's just some shortcuts that'll save you some time. If you're doing pre-cal, you'll want to know these because you will use them a gazillion times in pre-cal. I mean, we're going to use them a bunch, but not with the speed needed for pre-cal. Okay? So we are going to practice with these bunches today. That's what we're working with. We're going to be doing more factoring stuff. Some of them difference of squares, some of them perfect square trinomials, some of them not. So we're going to kind of play with stuff. And we're going to start with these two where we're being asked to solve. And we're going to solve this by factoring. There may or may not be other options for how to solve it, but we're going to start with solving it by factoring. So this first one, x squared is a perfect square, 144 is a perfect square, and they're being subtracted. So this one is a difference of squares. That's definitely a U, not scores. So what we can do is we can work on remembering that special pattern. It takes two sets of parentheses. The piece that was squared to make x squared, x. What number, when squared, gives us 144? 12. One of these terms gets a plus. One of these terms gets a minus. And the equals 0 is still sitting there off to the side. I highly recommend learning this pattern. It is 100% okay to X and box it. It will work. It'll get you the same thing. Remembering these patterns will save us time in the future. Like, it's going to come up. This will come up. I'm trying to think of a chapter that doesn't have it. It's going to touch in every chapter that we have through the end of the year. And I know I keep telling you that about lots of things, but a lot of our things intersect. Okay, so then we're going to solve this just like we did with our factored form one in the bell work. To find our solutions, we take each of these terms. I want to know, when does x plus 12 equal 0? I want to know, when does x minus 12 equal 0? So this is how we find my two solutions. We take each of the terms and set them equal to 0. So on this one, we're going to go ahead and subtract 12 from both sides to get x equals negative 12. And on this one, we're going to go ahead and add 12 to both sides to get x equals positive 12. So we didn't have to draw an X in box. There are times when we have shortcuts, and this is one of them. Our next one is very similar, except this one's a trinomial. So let's see if it's one of our perfect square trinomials. And I'll show you how to do this one with the X in the box again. Let's do it with the X. So what is my A times C? 4. 1 times 4 is 4. And my b value is 4. Pair of numbers that multiplies to make 4 and adds to make 4. 2 and 2. So if we put that through the box, we have our x squared from our equation, our 4 from our equation, that's these two pieces. And then we have our 2x and our 2x, right? Pulling our factors, we have x and 2, x and 2. If you get the same number on either side over here, that's when you really have a clue we've got a perfect square. Because we have our terms x plus 2 squared equals 0. Or x plus 2 times x plus 2. This is a perfect square trinomial. So to find our solution here, we're going to say, when does x plus 2 equal 0? X plus 2 equals 0 when x equals -2. Okay. Questions on these two? Okay. So sometimes they're not quite so obvious. So this left-hand one, we want to see if this is a perfect square trinomial. So what piece, when squared, gives us 4x squared? What? This is the same thing as 2x squared. What number, when squared, gives us 25? 5. So those are our two pieces that we're going to use to put together this special product. Thank you, sir. So those are our two pieces for this special product. Because our middle term, remember that was 2 times this times that. 2 times 2 is 4 times 5 gives us 20. So it does fit the pattern. So this is a perfect square trinomial where it's 2x plus 5 squared. As long as the middle term is 2 times each of the pieces, one from the front, one from the back. You don't have to X and box it. You absolutely can. 100% totally fine. 4 times 25 gives you 100. Pair of numbers that multiplies to make 100 and adds to make 20. You're going to have 10 and 10. You're going to put it through the box and you will get the exact same thing. Noticing these special products is not a replacement that we have to do instead of, it's a shortcut. So if you are comfortable factoring other ways, go for it. It will still work. This is a shortcut. Because now we're going to solve this. I want to find my solution. We want to know, when does 2x plus 5 actually equal 0? So we're going to start with subtracting 5 from both sides to get that 2x equals negative 5. And what do we do to get x by itself?
Divide by 2.
Divide by 2. Negative 5 halves. Or negative 5 over 2. And that's okay. We're going to get fraction answers sometimes. We are allowed to get fraction answers. Okay, let's do the next one. 9x squared minus 25 equals 0. This one's a little easier to spot because this one is a difference of squares pattern. It's only got 2 pieces. And they are both perfect squares. What is the piece that was squared to make this guy? 3x when squared gets us 9x squared. What number squared gives us 25? 5. That lets us put together our special pattern. 3x goes in the front. 5 goes in the back. 1's a plus, 1's a minus. Difference of squares will always have 1 as a plus, 1 as a minus. Every single time. 1 is a plus, 1 is a minus. So then to solve it, we set each term equal to 0. We want to know when does 3x plus 5 equal 0. And we want to know when does 3x minus 5 equal 0. So on our left-hand one, we're going to go ahead and start with subtracting 5 to get 3x equals negative 5. Then we're going to divide both sides by 3 to get x equals negative 5 thirds. And it's really similar on the right-hand side. We're going to add 5 this time to get 3x equals positive 5. Therefore, x equals positive 5 thirds. Okay, so these special products are going to come up on the fairly regular. We love to do these, and the books love to do these, and things like PSAT loves to put on special products. They love it. Speaking of PSAT, that's Wednesday. So my sophomores and juniors, you will be here to take the PSAT. You need to bring your Chromebooks and your charger. Ideally both charged and with the charger. Just saying, because that's the problem we had last year. Chromebooks kept dying. They were like dying. Okay, Wednesday. So I'll read the official blurb that they asked me to read. Boop. 10th and 11th graders should arrive on time on Wednesday to take the PSAT with fully charged devices and bring your power cord just in case. You'll get an email on your Pike account to notify what room you'll be in. 9th and 12th graders do not come to the building. They have a choice on what to do for job shadowing or community service. Otherwise, you have an alternative assignment. Okay? So, I'm gonna hand out a worksheet today. We are also gonna be using it tomorrow. So like, don't freak out on me. So homework 4, it's factoring, it's special products. Our next quiz is the Friday before Halloween. So it's the last Friday in the month. So, next Friday, about 2 weeks. Okay, so these are all things we've done. We're gonna talk more about solving with these special products and with our factoring tomorrow. I just don't wanna, first day back, right off the bat, talk the entire time, bell to bell. Holy cow, when the brakes for the sled. I'm not ready. For me to talk the whole time. The first day back at 7 o'clock in the morning. Yeah. Rex. All right, so you guys have 8 minutes until the announcements start. Okay, so we'll work through some more things like this tomorrow. I'll make sure to hit one like the story problem tomorrow. And then we'll kind of get into kind of the meat and potatoes and weird stuff on Thursday.